Hi, welcome to the third module of LISP Your Mesh to Shape. Now that we have examined the tools with which we will be working, we can start meshing things up. Autolisp is frequently used as a scripting language in order to automate frequently used tasks. This is done by letting the program supply the information the user would have to enter in an interactive fashion from the command line or picking on the screen. Creating mesh objects is no exception. Typically, it would involve not only calling commands, but also setting certain system variables. This module will show how this can be done. What's a mesh? A mesh is a surface object. That is, unlike 3D solids, it has no volume or mass properties. It's made up of faces, which in turn are surrounded by edges, and these edges are specified by pairs of vertices. Meshes belong to the kind of objects known in computer graphics as subdivision surfaces. These objects can have different smoothing levels. Increasing the smoothing level generates facets that increasingly approximate rounded forms. By the way, you can notice we're using as an example in this slide a dodecahedron, which is not included in the mesh command primitives. This shape was created using some of the Autolisp functions we will be explaining in one of the next modules. We have two ways of making mesh objects through Autolisp. We can use it as a scripting language to automate the command interface. Or we can use the Autolisp endMake function to create mesh objects directly without the limitations of the different commands. For example, the dodecahedron shown in the previous slide is practically impossible to generate as a mesh using commands. These two ways of making meshes are available both in the Windows and Mac versions. But in most cases, arriving to those amazing shapes we want to have in our designs must be done through successive transformations to our meshes. This can be done once we have made the mesh by modifying the position of its vertices. If we use the Autolisp endMake function to make them, we can use the Autolisp endMod function to modify their geometry by transforming their vertices. endMod is available both for the Windows and Mac versions. Windows users can also do this using the properties exposed by the ActiveX interface. But our demonstration will rely on the classic Autolisp way, which is available both for Windows and Mac users. The mesh command supplies a set of so-called primitives, an assortment of simple shapes like boxes, spheres, cylinders, and so on. The number of faces in each of these shapes can be set through the Settings option. Mesh objects are now also created by the old polygon mesh creating commands: ruleSurf, tabSurf, repSurf, and edgeSurf. In these cases, the number of faces depend on the surftab1 and surftab2 system variables. The number of faces or tessellations for mesh primitives can be set using the meshOptions command, but this command uses a dialog box that cannot be suppressed, so it is not adequate for its use in AutoLISP programs. In AutoLISP programs, we'll rather use a set of system variables identified by the divmesh prefix that set the tessellations for each of the primitive's dimensions. As an example of how we can automate the mesh command, we have defined the cmd-mesh-box function. This function receives as arguments the box center point, the x, y, and z dimensions, and the number of divisions along each of these directions. The division values are assigned to the div mesh box length, div mesh box width, and div mesh box height system variables using the setVar function. Then the mesh command is called, this time using the vl-cmdf function, which is a Visual Lisp enhancement of the classic AutoLISP command function. The screen capture shows how this function is called from the command line and the way the AutoLISP command operates by supplying automatically the data which the mesh command prompts for. In this case, a box centered on the coordinate system's origin with a length of 100 units in the x, y, and z directions, and with 1 division in length, 2 in width, and 3 in height. Let's see how this works actually in the AutoCAD window. Another example is the cmd-square-mesh function that, in this case, uses the edgesurf command to create a flat square mesh using 4 lines it previously draws and then erases. In this function, we have used some advanced Lisp procedures using the apply and mapcar functions, which are explained in detail in the handout. We will be using a mesh like this one to demonstrate how to obtain a variety of shapes through the modification of the vertices coordinates through AutoLISP. We'll open the watch window, which lets us inspect each value returned by a Lisp expression. As this function involves a higher degree of complexity, we will set a breakpoint to halt its execution and the Step Into button for evaluating one by one its expressions. Each time the Step Into button is pressed, a new expression will be evaluated. This way, we can see how the lines are drawn one by one and the edgesurf mesh then created through the command. We've seen how we can automate the creation of mesh objects using the AutoCAD commands. This can be a great help, but with the mesh command we'll be limited to those basic shapes included as command options. And when using the commands that create mesh objects from other 2D or 3D entities as ruled, tabulated, rotation, or defined by edges, the process is prone to errors as we must program the creation of the initial objects only to destroy them once the mesh has been created. Our next module, to make a mesh, shows how mesh objects can be directly created without using AutoCAD commands.